So now that we've finished our discussion of splitterators, it's time to take a look at the other end of a stream and start talking about the so-called collectors. And we're going to start our discussion by focusing on something called non-concurrent collectors, as you'll see in a moment. So this particular lesson will give you an understanding of the structure and functionality of non-concurrent collectors, which are designed to be used for sequential streams. Now, we'll also see that you can use non-concurrent collectors for parallel streams as well, but that'll be a topic for the next section when we start talking about parallel streams. So as we've discussed earlier when we were talking about the collect terminal operation, collect is a terminal operation that uses something called a collector to accumulate the elements in a stream into something called a mutable result container. And as you can see here, a very simple example that we've looked at before. Basically, we create ourselves a stream, and then we collect the results of the stream processing into a list, which of course is implemented as an array list under the hood. And the array list is created by the toList factory method on the collectors utility class. Collector itself is something that's defined by a generic interface. Recall what a generic interface is. It's basically something where you can have certain types that are provided by the programmer when they instantiate an instance of the generic interface. And we'll talk more about the different types that can be instantiated here in just a moment. Collector implementations can be designated in one of two ways. They can either be designated as non-concurrent, or they can be designated as concurrent. And the way that they're designated is based on some characteristics, which is essentially metadata that's used to describe the properties of the collector. And this metadata is used by the streams framework in order to carry out the appropriate and given semantics of the programmer. The distinction between concurrent and non-concurrent collectors is only really relevant for parallel streams. And as we'll see later as we get further on into this, with sequential streams, which is what we're looking at here, you would use non-concurrent collectors. For parallel streams, you can either use concurrent collectors or non-concurrent collectors. That may seem a little odd at first because you might think, well, gee, how could I use a non-concurrent collector for a parallel stream? And don't worry, I will explain all that when we get to that point. Our focus here will be on non-concurrent collectors for sequential streams, and then we'll cover the non-concurrent and concurrent collectors for parallel streams at the appropriate point, probably starting as early as next week. So a non-concurrent collector for a sequential stream just is used to accumulate the elements in the stream into this thing called a mutable result container. And I think of it, I don't know why I have this image in my mind. I think of it like putting coins into a piggy bank. You collect the coins and you end up, when you're done, with your loot, with your money that you've collected. The collector is essentially the inverse of a splitterator. So if you recall from our earlier discussion, the splitterator partitions an input source up into a stream of elements, which are then processed either sequentially or in parallel. And then the collector is the inverse. It takes the stream of elements that were initially partitioned and then later processed as a result of the splitterator's partitioning behavior, and then combines things back into a single so-called reduced result. So you can kind of think of these as almost like bookends of the overall unfolding story of processing by your stream. So that's the quick overview of non-concurrent collectors. Obviously, at this point, you would really not understand how to program them in any special way, but don't worry, that's what we'll cover in the next couple of lessons.